A full AI workflow, I find, is not actually that useful because of the non-deterministic nature of LLMs.
We are going to start our second part of talks with Obie. Obie, he's a very well-known member in our Ruby community. He's known as an author and known as a co-founder. I will not go into all the details about what Obie did so far or what he's doing.
Hey, thanks, everybody. Thanks, Lucian. Thank you, Adrian, for the invitation. Cool. So I call this a survey. The idea is to give you a walkthrough of what's available at this moment in time. This field is moving super, super fast. I'm going to walk you through a number of different categories of Ruby libraries that are related to AI, specifically around how you can use AI to build systems, meaning your implementation of your system. So I'm not going to talk about Copilot and Claude Code and Claude Swarm and some of those other cool kinds of things. Trying to keep the talk within 20 minutes, but I'm going to talk about chat completions, agentic systems, what I call structured AI workflow, and I'll explain what that means when we get to it. Evals, which is a way of checking the performance of your AI system, and also finally FastMCP. Real briefly, in case some of you don't know, I've been doing programming professionally in my career for about 30 years, programming longer than that. I started using Ruby in 2004, Rails in 2005. So I've been doing Ruby for 20 years now, even though that seems incredible. Probably most famous as the author of The Rails Way, but I've recently written a book called Patterns of Application Development Using AI. A lot of you really like that book. Towards the end, I'll give you a QR code to be able to get the book for a significant discount if you don't have it yet. In addition to that, why am I qualified to give this talk specifically now? I have been doing AI stuff for over 2 years now, starting with a framework called Magma Chat that was kind of like a clone of ChatGPT that I released way back in RailsConf like 2 years ago. And I'm also creator of Shopify's Roast framework, which is a framework for doing workflows. I also maintain a whole bunch of Ruby gems related to AI. So the first category of Ruby libraries that we're going to talk about have to do with doing chat completions or prompts. I'd like to see a show of hands. Raise your hand if you've actually used chat completions or prompting inside of an existing project that you're working on. Okay, so it's a fair amount of you. In Ruby? Yeah? Okay, good. So we're going to go over the different gems that you can use to do that sort of thing. Probably if you've already done chat completions, I'm guessing many of you have used the OpenAI gem directly, right? That's probably the most common choice. There's other choices as well, and there's reasons to go with one over the other. And that mainly has to do with the abstraction level that you're after. So in this survey of the different tools and libraries that are available, I've categorized them on a low, medium to high scale of abstraction. And I wanted to take a moment before going into that list to explain what I mean by that. So the low abstraction level, as you might imagine, gives you direct access to the provider API methods. So in the case of OpenAI, that would be creating a chat completion. More recently, that would be creating a response, which is where you keep the state of your conversation with the AI on the server side, as opposed to having to manage it yourself. And this can be done with libraries such as Ruby, the Ruby OpenAI gem. As a consequence of being at that low abstraction level, you do need to manage your own context. And then there's other things that you have access to that don't necessarily fit into the paradigm of a chat completion. So that would be, for instance, creating embeddings would be something that's available through a low abstraction level. creating images, things that are specific to particular providers. In that medium category of abstraction level, the Ruby gems and frameworks that I'm talking about start to introduce classes for representing prompts, conversations, chats, etc., as stateful first-class objects. So they're starting to go up in that abstraction level and give you assistance in terms of the kinds of operations that you want to do, but it's still, I would say, chat-centric. You're still thinking about the way that you're using the AI in terms of a conversation and its context. But those libraries do provide prompt management features, let's say. And then finally, at the high abstraction level, you're partially or completely hiding the fact that you're having a chat or conversation with the AI completely. And at that point, the AI is becoming more of a black box where you have an input and you have an output, or you have a result that you're looking for, whatever the case may be. An example of this, which I'll talk again briefly when I cover the RAIX gem, is that RAIX provides a predicate class, and a predicate class has a certain context, but it's not a conversation at all. You're basically posing some input and you're expecting a Boolean result, which is why it's called a predicate. So first of all, at that lowest level of abstraction would be the OpenAI gem. This also applies to many other gems that are specifically for particular providers. So one that many of you may not know about unless you've been hanging out in the Ruby+AI Discord or kind of in this field, is one that I wrote called the Open Router gem. And the Open Router is one of the, I think, the coolest services that's out there, because through a single API, you can access pretty much every single commercial and open source LLM that's out there. And they give you a mapping, and they give you many, many other value-added services on top of that, so that through one layer, you can get access to any of these models, switch amongst them at will. You have fallback in terms of models, in terms of providers. If one goes down, it can automatically fail over. An example would be is if OpenAI is having a bad day, it falls back to Azure to provide the same models. If Anthropic is having a bad day, it can fall back to AWS, etc. Going through these kind of quickly, RubyLLM, if we map this ecosystem, let's say, to early Rails, I would say RubyLLM is probably the closest thing that we have to Rails. I suspect that it's probably going to come out ahead. In terms of being the main kind of kitchen sink type of framework for doing this kind of work in Ruby. It provides low to medium abstraction level, and it's unfortunate that it's so difficult to read the text there, but essentially it gives you, in addition to the ability to do chats, you can have multimodal, quote unquote, chats, meaning that you're attaching media in the form of images or audio files, etc. You can stream responses, which is kind of like basic. It can also let you generate images, create embeddings, and is even starting to provide abstractions such as tools. So the fact that RubyLLM has a base tool class means you can extend it to add function calling to your chat completions. ActiveAgent is another option in this same category. The abstraction level is also low to medium. I respect this work tremendously. I respect Justin and the work that they're putting into this. I think the name is a little misleading. It's called ActiveAgent, but it's not really an agentic system as far as I can tell. There are other agentic systems that are more about agent behavior, where the AI agent is actually, you give it a directive and you kind of let it run wild in terms of accomplishing what you want it to accomplish. That's not really what this is. ActiveAgent has tight integration with Rails, however, and it gives you the ability to, for instance, define prompts in standardized ways as templates. They kind of, if you look at it sideways, the way that they define prompts in ActiveAgent kind of looks like the way that you define templates for Action View in the framework. But it does have some cool features. Again, this is a survey. I'm really just trying to expose you to some of these libraries that you may not have seen before, so that you can get inspired to use them yourself. In their example, which is, they define an application agent. Again, this is not exactly an agent. It's really just a wrapper for a prompt. I'll give you some example code here. They also have the ability to do structured output, which is another common abstraction. It's like basically a way to provide some sort of usually JSON schema that says, hey, the output that I want you to give me, I don't want it to be free form. I want it to be in this specific schema. And if for those of you that have been trying to work with structured output for a while, you know that this can be challenging. Quite often you'll say, hey, I want a JSON response. And when the AI responds, it'll say, here's your JSON response. And then it gives you the JSON. So you have to jump through hoops to like strip that away. Anyone who's tried to do regex type extraction of JSON knows that it's a pain in the butt. That sort of thing is not necessary anymore. So if you have been doing AI programming for a while and you haven't kept up with the kind of things that are available, there are much better options. Finally, my favorite, because I wrote it and maintained that, this is extracted from Olympia, which is an app that, like an AI system that I maintained for 2 years. I call it RAI for Ruby+AI extensions. And I call this a medium to high abstraction level because it attempts to give you basically 3 mix-ins that you can add to any class in your system to give it the ability to do the chat completion, but you're not calling the methods directly like on the low-level API. The 3 main capabilities that RAI gives you, the first one I already mentioned, which is to like actually do a completion. The 2 which I think are a little bit cooler, are the ability to do function dispatch. This is basically like the tool definition that I showed you in the last slide, in ActiveAgent. But if you can kind of see what's written here, it's in a declarative fashion. You're saying, hey, there's a function that I want to provide to the AI in the process of responding to me. In this case, it's check the weather. So you provide a symbol, a description, the parameters, and in this case, the implementation of this function is just in this block, and right now it's just saying it's hard-coded to respond hot and sunny. So that's function dispatch, and that has a lot of rich functionality around what you can do with functions. And there's another really cool feature of RAI, which is the ability to mix in prompt declarations. And when you mix in prompt declarations, at that point you can start to compose your prompts together. So you can have one chat completion class that encompasses many different prompts, or a chain of prompts. Prompt chaining is a pattern that I talk about in my book. In this case, this is a class taken from Olympia, which is the subscriber that's responding to a prompt event, the fact that the user sent a prompt. And amongst other things, it's calling, before it actually does its final response to the user, it's fetching any URLs that might be present in the prompt, and it's doing a memory scan. So it's looking for previous topics that were discussed with that user. Still within the category of chat completions, this is a cool project that I also did called Desiru, which stands for Declarative Self-Improving Ruby. And the abstraction level for this is totally high. So in this case, what you're using the AI for is as kind of like an implementation of a computing system. So it's a way of writing AI in logic in a way that eliminates prompts as much as possible. So in the case of, I don't think there's any way I can zoom this, unfortunately, but the most basic function of, is there a pointer on the remote? Okay. The most basic module in this kind of system is a prediction. And the prediction is modeled as a question leads to an answer. So you're describing what it is that you want the AI to do, but you're not describing it in terms of a prompt. You're kind of describing it in terms of a function. So in the case of this prediction, you can call it with a question, what is the capital of France? And then the result will contain an attribute containing an answer. This is a very, very basic, kind of abstraction. There's also additional abstractions that map to techniques for AI prompting. For instance, chain of thought has the same kind of schema. So a question leads to an answer, but the fact that you're using a chain of thought means that it's going to do some reasoning, and that reasoning is exposed to you in the result. And finally, the most complex implementation would be a program of thought. And in this case, oh cool, you're zooming it for me. How awesome. So thoughtful. Okay. So in the case of a program of thought, you provide the signature, and then what it's going to do is actually reason about the problem and then generate some Ruby code. But normally the implementation of something like this would take a lot of prompt engineering. Basically what Desirou and frameworks like this is they provide the actual boilerplate and underlying mechanisms for performing this for you. So in this case, if the question is, if a train travels 120 kilometers in 1.5 hours, what's his speed in, miles per second or whatever? You don't want the AI to try to do this with language because it's probably going to hallucinate a result. The better approach is for the AI to think, okay, in order to answer this question, what kind of program would I write? So basically this gives you the ability to do that. This is probably the most leading edge stuff, and a lot of people like Toby at Shopify are very excited about this kind of approach. So if we could zoom out again, yeah. So this is a competitor to Desirou. I think they're actually killing it. I hate the name though, because the PY in DSPy stands for Python. So it's just declarative self-improving Python.rb. So I like my name better. It's all vibe coded anyway. So write your own if you want to. So anyway, that's my survey of the different kind of chat completions. There are others, but I think they're much smaller projects and don't have as much traction. In terms of agentic systems, which is, an agentic system is one where you have a self-directed AI agent, so you give an instruction to an agent. Most common kind of use cases for agents these days, I think one that potentially many of us have actually tried with the consumer projects is, for instance, like deep research. You can tell the agent, hey, I want to collect data on fill in the blank, architectural trends in the late 1800s or something, and you set it loose and then you give it some tools and you just let it continue iterating for a while. So you're trading time for results. Whereas a chat completion is do the best that you can and give me a result right now. An agent is do the best you can and take a certain amount of time or take as much time as you need. Within a budget. So the only viable agentic gem that I could find in my survey is actually called Agentum, and it's a plan and execute CLI. So even though it has a programmatic interface, it does have an API that you could use within your own programs. The great thing about it is that you can just install it as a gem and start using it as a CLI from the command line. And it gives you the ability to do things like deep research. It also gives you the ability to save and reuse your agents across sessions. It's just a very, very good way to use agents very easily from the command line. And it has cool advanced features like improving the performance through execution history analysis. This is actually something that's part of DSPy that I did not discuss because of time constraints. But there's this whole, let's call it category of type of functionality that people are starting to develop with AI where it's like self-improvement loops. And this has that. And it's a pretty full-featured text UI. So it's got progress bar spinners and colorized output. I'll show you real quick. And if we could zoom in, please, on... But basically, this is what it looks like to use agentic from the command line. So you tell it to create a plan, you can tell it to save the plan to a file, and then you tell it to execute the plan. This is broken into 2 steps, and I think that's actually really wise to do it in that way. because quite often the execution of the plan actually eats up a lot of tokens and can become very, very expensive. So it's good to have the ability to iterate on the plan and make sure it makes sense before you set it loose. The third category, and also one that's near and dear to my heart, is structured AI workflows. And the reason is that a lot of the things where AI is most useful, especially in a business setting, has to do with inserting bits and pieces of AI into otherwise normal kind of workflow processing. I see some of you nodding your heads. A full AI workflow, I find, is not actually that useful because of the non-deterministic nature of LLMs. I haven't found, in the last year or two that I've been working on this or thinking about this, that many cases where a fully non-deterministic workflow execution actually performs well. There's too many opportunities in the early steps for things to go out of bounds and then ruin the rest of the workflow. It's also very slow and inefficient and expensive. So that's why I created Roast. Roast is a gem. It's a framework for writing workflows. Is kind of a workflow execution library, basically. You can write non-AI workflows in Roast. So it's just basically a series of steps. But what's good about Roast is that it lets you very, very easily mix deterministic with non-deterministic steps. So what's a deterministic step? A deterministic step is use ripgrep to scan through my log files and find, certain occurrences of blah, blah, blah. Run JQ across this big batch of JSON and extract, whatever it is you're looking for. That's a deterministic step. You want to use existing tools, non-AI tools, to do that step. But then whatever you got from that, you want to run it through some AI, like, hey, decide if there's a security violation here or if there's something suspicious. And then maybe the suspicious thing, you pull it out. Maybe you categorize it. That's an AI step. And then maybe you create some keywords. And then maybe you do a deterministic step to search in a database of, I don't know, vulnerabilities or something to see if it matches. That doesn't have to be AI. And then maybe that search, which is a deterministic step, brings back a bunch of results, and you want to look at those results. That's an AI step, to evaluate them. So that's what Roast is good at. It is strongly influenced by Rails in terms of being convention over configuration. You define it in YAML. This is an example of what it looks like. This is an example taken right from the existing source code. So analyze my business, examines a CSV list of orders for insights. In this case, this is just 4 AI steps, so there's no deterministic steps here. And a cool kind of convenience feature is that the steps can, if they're strings, they're actually just interpreted as prompts. So in this case, this workflow, it says use Gemini 2.5 Flash and provides 2 built-in tools. Roast provides like a whole series, like I think almost a dozen now, built-in tools. Amongst them are read file and grep. And the steps are read the provided CSV files, where are most of my customers from, what is my most popular product, and then summarize the insights from the report. Pretty essential to understand about how this works is that one workflow is one conversation context. So as these prompts are executed, they're being added to the context, and then whatever is in the last prompt is automatically output, is considered the output. Again, convention over configuration. You can customize all this. You can make all of these output, or you can make none of them output. The steps can have side effects, et cetera, et cetera. But this is kind of like the most default use case. So in this case, this would run, and at the end, the output from running the script would be a summary with the insights from the report. The reason that this last step can create insights is because it has access to the context that was generated by the steps previous to it. Here's another example. So in this case, we have more tools. You see here that you have the ability to scope what tools are available, and the steps here are symbols. They're explore directory, analyze files, and then write a summary. And these steps are coming from prompt files in the in the roast workflow directory. So wherever this file is, it's going to look for subdirectories called explore directory, analyze prompt files, write summary. And within those subdirectories, you can put a prompt file. The prompt is a markdown file that can have ERB. The ERB lets you, interpolate data into those prompts. You can also have post-processing. These could also be RB files or shell scripts so that they execute. It's very, very flexible. Roast, I should say, is in very, very heavy use at Shopify. As of the time that I left Shopify at the end of June, we had about a dozen different teams using Roast for many, many different purposes. The canonical use of Roast, and the reason it got its name, was because we were using it to critique test code. So we were running it on Shopify's enormous list of unit tests, looking for ways to improve. We've also used it to generate code, both production code and test code. And it's also being used for many, many other things, from finding data in like the mountains of data that there is. During our hack days, I helped a team that wrote a Chesterton's fence. Some of you will get the reference. Kind of script that goes deep into the history of a particular line in a particular file. So it's kind of like git blame on steroids. And it will look even across file moves, across pretty much wherever that line of code came from, it will look for the commit messages and the PR messages and comments, anything associated with that code, and then try to give you a cohesive story about where that code come from. Why do you want to do that with Roast as opposed to an agent? Because if you decompose something like Chesterton's fence into a series of steps, you'll notice that you pretty much want to do the same steps over and over again. So you can try it at first with an agent and say, hey, do X, right? Like, tell me where this line of code came from. Here are some tools. And then you can look at what the agent did. But you got to realize that when you take an agentic approach, you're burning a lot of tokens, because the agent's thinking about it and it's reasoning, it's going back and forth, there's a lot of trial and error. And as it does that process, it's figuring things out, it's basically figuring out the workflow for getting to the desired result. Once that is figured out, you don't need to continue to figure it out over and over and over again. If it's something that you want to be repeatable, or if you want to run at scale, basically once the workflow is figured out, you want to codify it as much as possible. All right. I have a test creating example, but in the interest of time, I'm just going to go through this real quick. So there's a new framework, and there's a really, really good episode with, I think his name is Kieran Klassen, for this framework called Leva. And this is a Ruby on Rails framework for evaluating LLM performance. An eval refers to basically something you can execute to get a certain result from an LLM. And then the eval part is that you're actually asking an LLM to evaluate whether that answer was correct. You don't have to ask the LLM, but a lot of times this is used for like kind of free-form, non-deterministic kind of responses or language responses where it's not trivial to do a regex or to check whether it's, result is in an enum. Anyway, the effectiveness of evals, there's a lot of chatter on Twitter in the last few weeks about like, hey, do evals actually make sense or not? I happen to think that they do make sense. I think it's very useful for most classes of AI systems to have some sort of eval system in place. And I'm not going to say it's a complex problem to solve, but it is a rather complicated problem to solve. So the fact that we have a framework for doing it and that provides a nice UI is actually pretty cool. Briefly, if we can zoom into the code here, I give some examples of what it looks like to actually extend the Leva base classes. So this execution is actually like this is where your chat completion would go. So you're doing a prompt, you're calling an API or running a local model, and you return the model's output. The evaluation is where you determine did that prompt respond something that was expected? So here in this case of this example, the expected label was part of the record. It was like part of the data set of the prompt. In some cases, this could also be dynamic. And then finally, the evaluation that calculates a score, and the score is what you're going to use to end up determining what the performance was. The nice thing about having a system like this is that when a new model comes out, as happens all the time, you go, oh, cool, we want to try this new model. This model is cheaper. Is it better, is what you want to know. So you run your eval system on it, and you can get a somewhat scientific answer instead of having to, kind of gut check it. All right. And finally, my last category that I wanted to talk about was MCP. MCP stands for Model Context Protocol. FastMCP is actually a pretty successful gem that's being used all over the place by many of us to wrap pretty much anything in a tool API that can be used by your LLM for completion. It's very, very well written, very highly adopted, has this kind of declarative interface where you can describe, in this case, this is a tool that creates a user, and this is how you define it. So you provide a description. The description is not just for you to remember what this does. This is the description that's actually passed to the LLM. So you want this to be comprehensive. Then there's the explanation of the arguments. It gives you a nice DSL for being able to say, whether it's required or not, the typing and the description. And then finally, what should happen when the LLM calls it? In this case, create a user. If we zoom out, please. In addition to this tools API, so basically MCP provides a number of different services besides tool functions, which is something that you may or may not be aware of. It also provides things like resources and prompts. FastMCP supports resources. It's a way of sharing data in a standardized way with your LLM. And it has multiple transports. I could speak a whole talk about the different transports and why you might pick one over the other. Basically, one is executing on your machine, that would be with standard I/O, and another one's meant to be served over a network, which would be the HTTP or SSE. It's also got framework integration with Rails, authentication support, et cetera, et cetera. Very, very cool tool. And I wanted to give you some additional resources. Basically, I want to give a shout out to Ruby+AI News. Matt's doing a really, really great job with this. I mean, basically, this is the one newsletter I think you need to subscribe to if you're doing a lot of AI stuff in Ruby. Pretty much every week he's coming out with a full roundup of everything that's going on. And there's a lot going on. I mean, basically, it was kind of tough to put together this talk because, it could have probably gone on for an hour or more just with all the different libraries that are popping up every week. So yeah, Ruby+AI News, there's the link. And all the action in this community, as Chris and others know, is going on in the Ruby+AI Builders Discord. If you want the invite, there's the QR code. So I'll leave it up for a minute more. But essentially, this is where most of us that actively work on Ruby+AI stuff hang out. It is fairly high activity, not super, not like every single minute or whatever, but there is a fairly active community in there, and it's a very, very good resource. Very friendly for when you're just starting out. You can definitely find many of us in there that want to help you. And finally, as promised, this is my book, Patterns of Application Development Using AI. I very, very purposely wrote this in as much of a evergreen fashion as possible. I'm proud to say that it is not completely out of date now, even though it was released, I think almost a year ago at this point. No, not almost a year ago. I don't remember exactly when I released it, but long enough ago that it's probably like a couple of years in AI time. But essentially what I went for in here was, okay, these are proven ways to use AI in your traditional programming. And again, I'm not talking about Copilot or Claude Code or things like that. I'm not talking about generating code. I'm talking about using code components in your Rails app, in your scripts that leverage LLMs to do part of the logic that would be either impossible or take hundreds of thousands of lines of code that you can replace with a prompt. And you'll get 50% off the minimum price, so it comes out to like $20 if you use this QR code here. So that's pretty much it. Thank you very much.